My name is Dr. Mike Murphy. I'm an assistant professor of computer science and information systems at Coastal Carolina University. In this lecture, I'm going to discuss requirements analysis. In particular, I'll give an overview of different types of projects, different types of resources that can be applied to projects, talk about the purpose of performing requirements analysis, discuss stakeholders, interests, and actors, and talk about the functional and non-functional requirements of development projects. Software development projects can be described as falling into a range in between two extremes. At one extreme, we have something called a greenfield project. And it's called a greenfield project because it's analogous to building a building on an empty field. Start with a grassy field, build everything from scratch. It's a completely new system. You get to make all the design decisions from the ground up. There's no existing code that has to be merged into the system. And this type of project has the potential to be extremely rewarding to the people who work on it. At the opposite extreme, we have a re-engineering project, or a project that needs to be re-engineered. This type of project begins with a pile of existing code that lacks any type of documentation whatsoever. The design of the system, the architecture of the system is an unknown. And in fact, it's necessary to perform code analysis to determine how the application was designed and how it was architected. This type of project has the greatest potential for frustration, since many older programming paradigms did not emphasize making code that was easy to untangle. Most projects fall in between these two extremes. There are some projects that fall into the greenfield category. There are some re-engineering projects. However, many projects are going to land in the middle. There's going to be some amount of code that has to be reused, yet there'll be some amount of documentation, at least hopefully. Now, regardless of the type of project, we can utilize several different types of resources in the software development activities. Of course, we begin with people. We have a number of people who work with us on a software development project. We have software architects, we have designers, we have developers, we have programmers, we have others. One other type of person that I didn't put in the slides but is important is someone called a domain expert. That's the type of person who knows what types of problems the software actually needs to solve and what the business rules are for that class of problem. Of course, we also have money and infrastructure. Infrastructure includes things such as computer equipment, software applications, desktop environments, other computational resources that we can utilize in order to develop a working solution. Of course, given enough money, we can always purchase additional resources in terms of additional infrastructure or hire additional programmers, consultants, others to help with the process. Now, the purpose of performing a requirements analysis is to make effective use of these resources that we have available to us. Ideally, we'd like to keep our development staff happy, we would like to spend our money wisely, and we'd like to optimize use of the infrastructure. We have the aim of trying to determine what exactly needs to be developed so that we can build the right product, so that we can actually make something that satisfies the business needs of whoever has commissioned the product. Speaking of folks who have an interest in the product, we can define a few roles and relationships for specific individuals within a software development setting. One important class of individual is the stakeholder. Stakeholders are people or other entities, such as companies or groups, that have a vested interest in the system under discussion, what's often called the SUD. Stakeholders include the customer, the development company itself, users of the system, and other direct participants in the system. However, stakeholders may also include indirect participants in the system, perhaps another agency or another unit of the company is actually funding the development work, even though they may not directly use the resulting product. These entities have a vested interest in the outcome of the system because they have an investment in the system. Now, the interests that one could associate with stakeholders are simply the expectations that a stakeholder has of the system under discussion. These interests may be of a technical nature, but they could also be of a financial nature or even a political nature. Perhaps there's some aspect of the system that has some political significance to someone. So, interests fall into a variety of categories. Actors in a system are anything that has behavior. So, this includes both human users and other computer systems. The primary actor in a system is a stakeholder that is using the system directly to carry out some task. In other words, this is the user who sits down at the keyboard and actually runs the application in order to perform some business function. Supporting actors, on the other hand, are other entities upon which the system relies to complete a task. This could include something such as an external database system, an external printing system, some other functionality that can be described as having behaviors which the system requires in order to perform its business functions. This could even be a person who has to go and manually input some type of data into the system. Human actors typically require a user interface or a UI in order to interact with the system. Computerized actors, on the other hand, typically require something called an application programming interface or API in order to interact with the system. Now, when we're specifying requirements and considering what type of actions an actor can take with the system, we can divide the requirements into two sets. The first set of requirements is called functional requirements. These requirements specify what a software application does. In other words, given some set of inputs, this set of requirements should be able to tell you what the outputs and side effects of the system will be for that set of inputs. This is the design of the software. This is the low-level detail about how the software responds to particular different types of input. Non-functional requirements, on the other hand, specify what the software is. These are often called qualities of the software. An example of this is the so-called ERPS list, which includes usability, reliability, performance, and supportability. ISO or IEC 9126 also defines some other qualities that a software system may have, including portability and efficiency. Non-functional requirements are embodied in the architecture of the software. How is the software put together to meet these quality requirements? So in summary, the types of development projects that we could be considering vary from the extremes of greenfield to re-engineering projects. These projects are supported by resources including people, money, and infrastructure. Each project has stakeholders, and each stakeholder has interests in the system. Stakeholders who use the system directly become primary actors on the system. And software engineering requirements can be classified as functional, in other words, describing how the system works, what the system does, or non-functional, describing qualities of the system or what the system is.